So today the student will be able to use their understanding of solving equations algebraically, which really means, the algebraic method we're going to use today is substitution. In order to solve a system of equations with one linear and one quadratic equation. So let's think for just a second about what kind of answers we're going to come up with. If we are solving a system of equations, we've done that before with lines, and because they're all linear, and you used a matrix to solve them is how most of you liked it the most, or you could do substitution or graphing. But when we have a line on a graph, right, the solution to our system is technically the point that your two lines came together. So the solution was an ordered pair. We always needed the x value and the y value that they crossed at. Well, this is a little bit different because instead of having two lines, we're going to have one linear equation, one line, and one quadratic equation. Remember, quadratics make this U shape on a graph. So it's very possible today that we end up with two answers instead of just one. Because when we solve a system, we still want to know where they intersect. So we have two equations, we need to know where they hit each other. So we need to know where they have the same point. So it's possible we have two solutions. It's also possible that the quadratic and the linear only touch at one point. So we might have two solutions, we might have one single solution, or it's also very possible that your quadratic and your line don't ever touch at all. They're going to go like this graph here, they go in all these directions, and those will never intersect each other. So it's also possible to have no solutions, okay? All right, so that's just kind of visually what we're doing today. That's our goal. Now, in order to make this happen, we're going to use substitution, like I said. And really what you're looking for is the easiest way to do it is to get the linear equation to be y equals. So once the linear equation is y equals, we want to know where these are the same. So the substitution takes your equations and kind of puts them into each other. So if I know that this y is equal to all of this, then I can say that this y is also equal to all of that. So the first step, what's usually easiest, is make sure the linear equation is solved for y. All right, so then I can just substitute it in. So instead of y equals x squared, we're going to have everything that y is equal to. So negative 12x plus 36 equals, now copy the rest of that equation, x squared minus 11x minus 36. Okay, because I have an x squared, I'm going to have to factor in order to solve it. So I need to solve the equation for 0. Equal to 0. Now, we're going to be kind of specific in how we do this because if we're going to end up factoring, remember when you factor, you need your x squared term to be positive. So don't move the x squared. Leave it where it is. We don't want to end up making it negative. So instead, we're going to move everything from the left-hand side to the right. So we're going to add 12x. So we've got 36 equals x squared plus 1x minus 36 minus 36. So 0 equals x squared plus 1x minus 72. Okay, now we're going to factor. So two numbers that multiply to negative 72 and add to positive 1 is 9 and negative 8. So this is x plus 9, x minus 8 equals 0. So those are my factors. I need to solve each factor for x. So now I need to know what x equals. So x plus 9 equals 0. and x minus 8 equals 0. So that means x equals negative 9 and x equals positive 8. Okay, but remember, we're looking for an ordered pair where these two lines would cross. So in order to be finished, I need to know the x value and the y value of my point. So our last step is we're going to substitute the x values into one of the original equations and solve for y. So if I know x equals negative 9, I'm going to get my original equation, y equals negative 12, x plus 36. And I know that x is negative 9. So I can replace this x with negative 9 using substitution. So y equals negative 12. Instead of x, we're using negative 9 plus 36. So y equals negative 12 times negative 9 is 108. Plus 36, y equals 144. So that tells me that I know that if I put these two equations on a graph, they would cross at the point where x is negative 9 and y is 144. Okay, but it looks like I have another point. So I'm going to do the same thing with this x. So y equals negative 12. Instead of x, we're using 8 plus 36. So y equals negative 12 times 8 is negative 96 plus 36. So y equals negative 60. So I also know they crossed the ordered pair when x was 8, y was negative 60. So this quadratic and this line will cross at 2 points, negative 9, 144, and 8, negative 60. All right, example 2. First, I want to make sure the linear equation is solved for y. And it is. So second, I'm going to substitute. I didn't even write that up here. Technically, we substituted first. And then we solve for 0. Okay. So second, I'm going to substitute. So I'm going to take my equation equals this. So if y equals all of that, then this y also equals that. So we're going to substitute 3x plus 1 into y. So instead of y, we have 3x plus 1 equals, now copy the rest of this equation, x squared plus 4x minus 1. Now, we know we're going to have to factor, so we're going to solve for 0. And we're going to keep the x squared positive, so we're going to keep that where it is. We're going to minus the 3x. So 1 equals x squared plus 1x minus 1 minus 1. 0 equals x squared plus 1x minus 2. So now we're going to factor. So this breaks in x plus 2, x minus 1 equals 0. We're going to solve for x. So x plus 2 equals 0, x minus 1 equals 0, x equals negative 2, x equals positive 1. All right, so then we're going to substitute the x values into the original equation. So again, I'm going to use the linear equation just because I think it's easier. So if x is negative 2, then when I reuse my linear equation, I can put that negative 2 in place of x. I can substitute it there. So y equals 3 times negative 2 plus 1. So y equals negative 6 plus 1. So y equals negative 5. So if I put these two equations on the same graph, I would see them intersect where x is negative 2 and y is negative 5. But I also have this other x value I need to use. So y equals 3 times 1 plus 1. Y equals 3 plus 1. Y equals 4. So they will also intersect where x is 1 and y is 4. So again, we have two ordered pairs where our lines will intersect. Last we solved for y. All right, last example. First, I need to make sure the linear equation is solved for y. It's just the easiest. So if I look at my linear equation, it's y minus 30 equals 12x. Well, I need to solve that. So I need to add 30 to both sides so that I have y equals 12x plus 30. Those are not like terms, so you cannot combine them. This is the equation I'm going to substitute. So I'm going to take if y equals 12x plus 30, then this y also equals 12x plus 30. So now you have 12x plus 30 equals x squared plus 11x minus 12. Okay? We're going to make the equation equal to 0. So minus 12x. So 30 equals x squared minus 1x minus 12. 0 equals x squared minus 1x minus 42. Okay, so now we're going to factor. So this factors to x minus 9, x plus 8. Solve for x. So x minus 9 equals 0 means x equals 9. X plus 8 equals 0 gives you x equals negative 8. So now we're going to substitute for x and solve for y. So I'm going to go back to the original equation. Y minus 30 equals 12x. I know that x is 9, so I'm going to substitute 9. So y minus 30 equals 12 times 9. So y minus 30 equals 84. Add 30. Y equals 114. So I know that these two equations will intersect where x is 9 and y is 114. But now we're going to use the negative 8. So y minus 30 equals 12 times negative 8. So y minus 30 equals 12 times negative 8 is negative 72. We're going to add 30. So y equals negative 72 plus 30 is negative 42. So we also know that these two equations will intersect. Oh, wait. 9 times 8 is not 42. So this is wrong. My bad, guys. So 9 times... No, it's not 9 either. Ay. Okay, my bad. Two numbers that multiply to 42 and add negative 42 and add to negative 1 is not 9 at all. I don't know what I was doing. It is 7 and 6. So it should be x minus 7, x plus 6. So sorry. Yeah, so x minus 7 equals 0, which means x equals 7. X plus 6 equals 0 means x equals negative 6. Those are the numbers we should be using. Okay, so now substitute them in. So if we use 7 here, y minus 30 equals 84. Add 30, y equals 114. So I know they're going to intersect at 7, 114. Okay, then do the same thing here. Negative 6. Y minus 30 equals negative 72. Add 30. Y equals negative 42. So negative 6, negative 42. So again, these two equations will intersect at 2 spots. All right, that's it.